here, we discuss one by one. The basic static characteristics accuracy. Accuracy can be defined as how close the measured value to the desired specification value. For example, when we are performing a measurement, then we got the resultant out of the particular measurement. That measured value we have to compare with the desired specification. While designing the device, as the designer itself specified that this device is going to give this also output. So by comparing this design and the measured value, we can get the accuracy or we can check the accuracy of the particular measurement. Now coming to precision, here the multiple readings which we have done for the same instrument has to be compared, and then repeatedly which amount of input is repeatedly we are getting, we have to check it. And coming to linearity, the linearity is one of the property of the instrument where the output of the device varying linearly with respect to input. Then the maximum almost all the measuring instruments has to satisfy this linearity characteristics of the device. And coming to the fourth static characteristics of device is the resolution. Resolution is defined as the smallest change in the input of the device which may changes or which may cause a change in respective output. Then coming to the dynamic characteristics of the instrument is, these are again different categories: repeatability, reproducibility, fidelity, and lab. We discuss one by one. Repeatability. Repeatability of any measuring instruments represent that how the device can be repeatedly used for a specific measurements in various time constraints or various places or environmental conditions. Coming to reproducibility. Reproducibility of the instrument shows that how it reproduces the same output for multiple measurements. Whether for same measurement they are going to perform multiple times, whether the device is giving same amount of output or not, because it is reproducing the same output previously which generated or not, I have to check. And coming to fidelity, fidelity of or the one of the dynamic characteristics which can explain about the faithfulness of the device to reproduce the exact output. Fidelity of one of the fidelity characteristics of the instrument shows that how faithful the particular instrument can be reproduce the output accurately. And then coming to lag in sense it is a type of delay where it is going to provide. These are the various characteristics we have discussed for a measuring instruments, both static and dynamic and respect to classification. And coming to errors. Generally, error can be defined as the delay between or the difference between the desired value to the measured value. Yeah, already we have done experiments. We can compare the desired value or obtained value, the desired specification value. The difference between these two are going to call as errors. The errors can be classified into various categories. Those are gross errors, systematic errors, and random errors. Coming to gross errors, these are the errors generally occur for any instrument while performing the measurements. And coming to systematic errors, again these are classified into observational errors and instrumental errors. The observational errors may happen because of the users while measuring the particular measurement, they may be taken instead of 0.2 or 0.3 values of the CRO or milliammeter or voltmeter. If there is any small difference, instead of 0.3 we have calculated as 0.2, like there is small difference while measuring, the observer itself may happen. And coming to the instrumental's errors comes under the basic properties of instrument may vary according to the surrounding environment changes. Like because of temperature, we know that all electronic components, maximum electronic components are temperature dependent. If temperature varies according to the temperature, the electronic properties of the instrument or the basic elements also changes. If the basic element temperature changes, automatically what happens? Because of the parameter changes, overall instrument operation may be changes. Because of that, we may get some amount of errors. Those errors are called as instrumental errors, comes under systematic category of errors. Coming to random errors, these are the errors which occur apart from this gross and systematic errors. After eliminating or rejecting these gross and errors, systematic errors, even though there are existing amount of errors, a small amount of errors, called as random errors. The random errors can be calculated and eliminated with the help of the basic statistical analysis, like the average mean square value, root mean square formula. By using those static analysis, you can overcome the random errors. And coming to basic measuring instruments, we discuss about various measuring instruments. Let us discuss starting with basic DC-Voltmeter. DC-Voltmeter is used for the measurement of voltage levels from some range to range, 0 to some 100 millivolts or 10 depends upon the type of or range of voltmeter. Here the basic construction of DC voltmeter, here we are showing that a multiplier or a multiplier resistor connected in series with the galvanometer or a PMC meter indicator. We will show that this is the basic construction of a DC voltmeter. Okay, here the range of voltmeter can be varied by using different multipliers. Instead of this Rm, for example, if you are using 1 k Rm, 1 kilo Rm as multiplier resistance, it measures certain range that was shown 0 to 100 millivolts, 100 millivolts range. Now we want to extend the range of this voltmeter, then simply by using another multiplier resistance. Instead of 1 k, we can use a 10 k resistor. 10 k multiplier, then the range of voltmeter may extend up to say 1000 millivolts like that. Now in that way, by using different multiplier resistors, we can extend the meter range. Like simply we can use a switch here and by various multipliers. Say this is 1 k, 10 k, this is 1 k, another is 100 ohm. By using like this connections with a switch provided, we can select any other range of the voltmeter. Similarly, coming to DC ammeter, where we are going to measure current values. Here, the multiplier resistor has to connect parallel with respect to the meter indicator or galvanometer, where the resistor is shunted across the meter, which shows the basic DC ammeter connection.